Good evening, everyone. Welcome to this week's GEMS presentation on how to set up RGBW pixels on a WLED controller and things about that. It's going to be given by Ron Armstrong. And with that, Ron, it's all yours.
Thank you, everyone. Um, while I share my desktop here real quick, um, many of you in here probably already know a bit about me or have seen this kind of thing before. But for those watching afterwards, just real quickly, a little bit about who am I? I've been involved in doing animated LED light shows since around 2018. Been a very active member of the community. I've many years ago joined the FPP development and QA team, focusing on QA and issue reproduction. Been also a founding member of the Matos Designs M team, which is our consulting services through Matos Designs, and a very active Zoom room helper right here in the xLights Zoom room for many years. As a background in my day job, I'm a enterprise storage management consultant or slash data center architecture. That's my background. And quick fun fact, I also happen to be amateur radio operator for those that really care. Anyway, so if you've ever bought pixels and put something together, and you had an interesting outcome. Like here, I got a couple trees playing. But let me output the lights, get my zoom bar out of the way. But you get something different than what you expect, right? So if you're expecting this barge to be going off over both trees and one tree is not behaving correctly and one is, then you may have found yourself in the right place. That's an indicator of a misconfiguration for RGBW lighting. If you are using other controllers, I'm going to plug our xLights Gem series, which you're on here right now. If you go to YouTube and do a search for the xLights Gems channel and go to videos, and right in here, this little search magnifying glass and search RGBW, we did a quick video about 9 months ago last year on the same topic of RGBW pixels, whether they're pucks or pixels, on other controllers. Specifically in this video, I had used a Dragon Genius based controller, but if you're doing like a Falcon, Culp, or Genius, or any of those other pixel controllers, then this other xLights Gems video is going to be the one you're going to want to watch. It's a bonus gem, 4-channel warm white RGBW pixel setup. So if you're trying to do RGBW on other mainstream modern controllers, Falcons, Genius, Culps, etc., then that's your right video. If you're trying to get it running on WLED, then this is the video you're going to want to watch. You found yourself to the right place. So what is kind of RGBW? And this may be, we'll spend a couple of minutes on just some rudimentary stuff to kind of lay the groundwork, if you don't mind. But what most of us do are RGB, right? That stands for red, green, and blue. And RGB uses 3 individual LEDs in one node in order to make all of the different colors of the rainbow. So for example, a white will be what we call a mixed white. So if you turn on RG and B all together, you get a mixed white. Now, RGBW introduces a dedicated LED and a 4th control channel in order to get more of a real correct white as opposed to an RGB mixed white. So they become 4. I don't really like this graphic because it talks about 4 chips in one LED, but it's technically 4 LEDs. So to see that another way, I pulled up this graphic. So in RGB, nice and sequential, you get red, green, blue, red, green, blue, red, green, blue, red, green, blue, repeating, right? Every node equals 1 pixel equals 3 channels for red, green, blue, and it just repeats. When you introduce the 4th channel, you kind of get this little shift going on, and you have to configure your controllers and or xLights in order to know that that's a 4 channel so that each node will receive 4 control channels instead of 3. So that these graphics are kind of help as to why you get this kind of weird shift like we just demonstrated at the top of the video. WLED is going to be a little bit different of a setup on how to do this RGBW, which is why we want to do a separate topic on WLED type controllers. This would be good for any controller type that happens to be running the WLED firmware. Um, I'm going to flip to my xLights here real quick and talk a little bit about what we have set up. So I happen to have in this little test show folder set up a WLED. In this case, it happens to be an RGB2Go Tetra, whether it's a generic WLED controller or an RGB2Go or like a Wasatch Pixels or talking to somebody earlier today, I think, or maybe yesterday with a Bong 69. So those, whatever controller hardware you have, if it's running WLED, then this is going to be the configuration on how I get my RGBWs to work. Quick other logistics and layout. I've got two little mini trees here. These happen to be like an 80 pixel mini tree with a 20 pixel star. And that's for 100 total. The left side here happens to have some Evo domes in an RGBW. And my right side just happens to be standard bullet pixels, 12-volt bullet pixels, like we have used for many years. So I've got one tree that's RGBW and one tree that's just RGB. I also happen to have a little camera set up as a live action. So we'll be able to, as we go through and make our configuration changes, we'll be able to actually see the live outcome of what we're doing. So I think that's all the groundwork. So in WLED, I'm going to choose, I'm going to back up just a second, so I want to talk about something. In your WLED controller setup, we recommend, when using WLED, to use the DDP protocol. You can use E131. DDP is going to be more efficient, and E131 is very limited on WLED-based controllers. So when doing DDP, this keep channel number setting, you want to make sure that is unchecked. So for WLED controllers, you want to make sure you use DDP. We recommend DDP. And then you'll have this keep channel number setting that needs to be unchecked. So make sure that it's unchecked. It's what we call DDP 1 based. That's required for when your show player or xLights sends data to WLED. And we'll talk about one of the challenges of WLED based upon this DDP protocol. I think there may be some jets coming in. So if there's a eyes burning, need dark mode, no dark mode, whatever. Small trees or big chairs, both. Anyway, dark mode is for sinners, but never mind. The WLED. I'm going to recommend that you manually configure everything to work correctly in WLED first. If it's not working correctly in WLED, it'll never work correctly from xLights. Remember, most things in our shows are layers, right? You have a player that plays a sequence that outputs to a set of controllers, and those controllers have to take that input data, and then it translates it to the correct port and the correct output, and then it outputs the data to the actual pixels. So everything's in layers. So we're going to want to make sure that we can talk correctly via WLED first and foremost. So I'm just going to select a red on my WLED, and you can see that my right tree is obviously all red. My left tree is wrong. It's not working correctly. Okay, well, we need to go fix that. Change green, change blue. Everything works correctly on the right side, but not on the left side. So let's go into our config and LED preferences and see how that's set up. Now the Tetra controller from RGB2Go happens to be a 4 output WLED based controller. So there are 4 outputs defined here. 1, 2, 3, 4. What GPIO numbers are assigned with that output is not necessarily hard coded within WLED software, but it will be hard-coded for your particular hardware. So your GPIO numbers for output 1 versus output 2 versus output 3 may be different depending on your specific hardware. So just make sure and always refer to your specific hardware vendor, whether it's a RGB2Go. Helps if I can spell RGB2Go. And if I look at his particular controller on his website controllers, this one is the Tetra 4-port. And if I scroll down through the text in here, most providers of WLED-based controllers should have somewhere in their controller documentation which GPIO numbers to use for which port on the board. Whether you have a Quinn LED, Dig Quad, Dig Octa, Dig Uno, or RGB2Go, or a Wasatch controllers, you're always going to want to make sure you know which GPIO numbers are for which output. So when you configure an output manually, you have to specify the protocol of this. Now, in my case, the left side, my RGBW is on port 1, my just RGB is on port 2. So obviously the WS281X protocol selection is not the correct protocol selection because we're getting all kinds of mixed colors and stuff, and this is just not displaying as we expect. You also note that not everything is lighting up, even though it's configured for 100 LEDs, it's not lighting up 100. So with RGBW being 4-channel, 100 of the RGB would be 300 channels. Now, if it's a 4-channel pixel, you're only going to get 75 lighting up because 300 divided by 4 channel tells you 75, which is why not everything is lighting up on this tree. So there are two predominant protocols used for RGBW lights in our hobby. There are actually other protocols, but some of them are compatible with. So the most compatible one for everything that we use for most pixel types and all would be this SK6812 / WS2814 RGBW. That is the protocol type that my particular pixels are using. You may have like a protocol called UCS 2904. 2904 is compatible with the SK6812 protocol. So this is going to be the predominant protocol type you're going to use for RGBW pixels. I happen to have some puck lighting here as well, not currently set up in this demo, and they use TM1814, and TM1814 is a different protocol. So check your particular lights that you have, and most likely they're going to be SK6812 or WS2814 compatible. So that's the one I would choose for RGBW. Once I changed to RGBW, notice I got this auto calculate white channel from RGB setting. For right now, I'm going to leave this on none, and then we're going to describe a little bit about what that's done. That may not be the choice you want to leave it on, but for right now, I'm going to leave that on none. So now I've got this defined as a 4-channel SK6812. I'm going to save and go back. Every time I save, it always changes to the default orange color. I want to go back to like a red. Now I can see that both trees are exactly red. If I change to green, both trees are exactly green. Change to blue, both trees are exactly blue. So that is the right protocol type. You can see, and this is not the best camera, not the best positioning, but you get the idea. Let's take a look at white. So with this setting, these Evo Dome RGBWs, their W channel, their 4th channel, their white, is actually a warm white. That auto calculate setting I just talked about, we left it on none, which means when I go white, I'm going to do a mix white. It is actually using the RGB LEDs to do a mixed white. So these whites in real life, these look similar, but for anyone who's seen the Evo domes, they do have a different view to them than a traditional pixel. They're like an 8mm frosted kind of lens It's not really a lens, but I'll call it that. Whereas a traditional pixel has a little bit different lens. So you'll see a little difference here. But now I'm going to go back to my LED preferences, and I'm going to choose this auto calculate white channel to be accurate. Accurate means that WLED is going to take the values from that are in common between your RGB channels, and it's going to calculate what the fourth channel should be and actually use the fourth channel LED. So if I change this to accurate, now I'm getting the actual white LED, not the RGB mix white. And now if I go back to my camera, you can see very obviously that these are a warm white, not a mix white. So again, LED preferences, once you choose a SK6812 RGBW, you'll get this auto calculate white. Depending on the version of WLED on, that may be somewhere down in the bottom of this list for your white, but somewhere there will be a setting to auto calculate the white channel. Accurate means that your white will play on the actual white LED. If you do none or brighter or dual, you'll get different outcomes. So on your particular lights, if you're going to be next to another item, like these two trees beside each other, if I do white, this obviously is not what I want. So yeah, I might want to change this setting to get the actual outcome that I prefer for my white. So I just switched that back to like a mixed white. So these are kind of a closer looking white. In real life, they look much closer than they do on this camera. Anyway, so now everything works in LED, in WLED outputting wise. So if I can change whatever color, another real good test are these in between colors, like this little cyan color. In real life, those are pretty close. Your fuchsias, your yellows, because those are actually mixing RGB. So those all now line up. So now my WLED is set up with 4-channel. Saw some chats coming in on if there's any real questions there.
No
Uh,
questions.
no real questions. Cool. Perfect. Thank you, Andy.
Actually, real quick, for those that came in a little bit late, are those two trees connected to the same controller? Are they daisy chained or are
They're
they
not
two
daisy
different
chained.
controllers?
They're on two different outputs.
Okay,
So their left one is on output 1 on this controller. The right one is on output 2.
okay. Just for clarification, thanks.
Right. And on WLED, you would not be on any controller. I would never recommend mixing RGB and RGBW on the same daisy chain output, controller output. I will never recommend doing that. Always keep your RGBW and RGB on different outputs because you can get some real interesting outcomes when you mix that up. It can work depending on your controller and other settings, but yeah, I recommend not doing it. But
Ron,
yep, output
somebody
1 is the left tree RGBW, output 2 is the right tree, which is just RGB.
somebody asked what version WLED you're running here.
Correct, correct. So this is the one that came on this Tetra that I got from them. It's 14.4. I haven't redone an upgrade or anything on it yet, so it's 14.4.
But
I
on
I have not moved.
WLED,
Pardon me?
sorry, I was gonna say on WLED, you have to have them on different ports, right? You can't mix.
Correct.
So,
Correct.
so it's
Because the definition of your output and most controllers you typically have to have them all because when you define so to get into that, if a controller supports virtual strings, technically you can because a virtual string would allow you to define the 4-channel protocol versus a 3-channel protocol. WLED does not support virtual strings. Therefore, the selection of protocol is based upon physical output. So port 2 for 100 pixels is 281X. That's my standard RGB. And then port 1 in this case for 100 pixels is my SK6812 RGBW. So they have to be on different outputs for any controller that does not support virtual strings. Great questions, great questions. Yep, and keep them coming. But yeah, 14.4 is the current version here. I have not moved any of my WLED devices to 15 yet. I've got some devices that have been deployed for 5 or 6 years that are still on like 12, but mostly I'm in the 13 and 14 range, 14, 4 is what this one happens to be. Some of these settings that we're looking at would be different on different versions, but so now anyway, WLED is, outputting correctly and everything's fine. Want to talk a little bit about, because so far we've been using the WLED interface to output pixels, right? We have not received anything to receive into WLED. So let's talk a little bit about that. So I'm going to go to config and then sync interfaces. Config sync interfaces is where you can configure your real-time input to receive UDP input enabled. By default, on most instances I've seen, that is enabled. That allows it to receive either E131 or DDP. For DDP, there's nothing else here you need to configure. If you're doing E131 or ArtNet, because it supports ArtNet as well, you'd have to define the universe and like some start address. There's some other options you would have to be able to configure. This DMX input mode only is applied if using E131 or ArtNet input. So none of these settings are applied if you're using DDP input, which is what we recommend so you can exceed. Fun fact, in WLED with E131, it only supports 9 consecutive universes, which means 1,536 pixels on the entire instance. So with E131, you will never be able to control more than 1,536 pixels from like an E131 source sending input into WLED, which is another reason we support DDP, because you can do more pixels than that with an ESP32 based controller. Anyway, so DDP is turned on. There is an interesting anomaly with the way WLED implemented the DDP protocol. So they will only receive, they expect to receive, let me rephrase, they expect to receive any incoming DDP is in 3 channel per node packet. They do a map of incoming data stream to your pixels in the order in which they're defined on your output page, right? So when you go to your LED preferences, set your outputs, whatever the first block of data that comes in is going to assign that to pixel 1, and he's going to take 3 channels and assign it to pixel 1 regardless. So with DDP, he cannot receive 4 channel data per pixel. He can only receive 3 channel. There is a specific attribute in DDP that was not implemented in WLED implementation of the DDP protocol. So that said, it's switched now to xLights. Now that sends data. Actually, I still have my white turned on here. So let me get right back here, go back to, and another interesting thing with WLED, my preference, just a little tip and trick. On all my WLED instances, for anyone who's messed with it, right out of the box, brand new, when you first power it on, what happens? Your LED lights turn orange, right? It's kind of like their default out of the box color. I always select black for all my configured pixels, and then I'll define a preset. So I'll add a preset for black. In this case, I give that preset number 1. I'll go to config, LED preferences. Scroll down here a little ways, you'll get to defaults, and here apply preset number 1 at boot up. By default,
Right.
this is set on 0. But that way, every time you power on, it's going to apply preset number 1, which in this case is black. That way, if you go and have a reboot, your pixels will be off.
Okay, you can also turn that off, correct? In config, LEDs on at startup.
You can do that as well. Newer versions, this power button, older versions, if the power button was off, it would not receive data from the UDP input, DDP or E131. And I believe that's been changed in recent versions. That's something I haven't tested lately. Yeah, so that may be a leftover legacy thing the way I do it, but it's very possible because there is an LED preference if you scroll down here a little bit. In defaults.
It's right where you
turn
changed
on
it right there.
LEDs after power on reset. You could technically uncheck that as well. I would presume test that. So if you turn that off, cool. Then just test it. It still will receive data from xLights. As long as it still receives data from xLights, then you're in good shape. Fantastic. Yep. I have like, you know, one of the houses where I spend half my time. I've got like 9 WLED instances all around, and they're integrated in with the Alexa device that shall not be named. And so just have easy house control, and we have routines that turn things on and off. So I usually have like 8 or 10 presets on most of my config out there. And so I just make it a habit of doing a black preset as well. But yeah, regardless. Yeah. So knowing that when you're sending DDP into WLED, it's going to expect that incoming data to be in 3-channel sections. So in xLights, do not change your models to be anything different than your standard 2811 RGB models. So if you take a look at my model here, the left side, remember, is the one that's representative. Let's continue this train of thought. This left side is my RGBW. On other controllers, we'd have you come down and change the string properties type. And on your controller connections, we would change the protocol here. The challenge is, if you do this and then upload to WLED, it will not be correct, because then xLights will be trying to send 4 channels per node, but the receiving incoming to WLED will only expect to receive 3 channels per node. So you can never get it correct. So the correct recipe that I've had being able to do RGBW on WLED is to leave xLights as 3-channel. xLights is just RGB. All your models are RGB. Then you just send the RGB data into WLED, and WLED will automatically calculate for that 4th channel and automatically output correctly. So we'll see that in a demo here in just a moment. So string properties, the default RGB node. So these trees for string properties and controller settings are exactly the same. All right, so let me just go to an animation sequence here real quick. I'm just going to grab a quick on effect. Throw it here. Let me get my all the way out. So it's on the color red. If I output to lights, now sending from xLights, I get red as red. If I turn that off and go green, my green is green, and my blue is blue. I highly recommend, when doing testing with both RGB and RGBW, that you just drop like a simple on effect in a sample sequence here. Some of the test modes, because with WLED, we have our models set up as RGBW. Excuse me, the models are set up as RGB only, right? So in xLights, we leave everything configured as 3-channel RGB. So the testing from tools test will still work correctly as expected. But with other controllers, if you're doing RGBW, the best way I find to test when you have mixed pixel types is to just throw an on effect. In this case, I just created an everything group, but whether it's on an everything group or if it's on just a specific model. And I can't arrow when, in the newer versions of xLights, I can't arrow this down because I got a blocker in the way here, right? So I got to cut and then paste. So if I put this on just the tree left only. Let me get rid of this. Don't need that anymore. Now I just got that tree only. So whether I'm on an individual model or if I'm on the everything group, this test will be your true test if everything is configured as expected. Test that real quick as well, but throwing a butterfly on there, not the candle. So you can kind of see these images and everything kind of flowing from the top right, because I got that across the group. And on my camera, you can kind of see that red banner You can kind of see that red stripe come through and flow across everything. So the key is configure the 4-channel in WLED. Configure it as 3-channel in xLights. So with that, I'm going to go to the controllers tab and visualizer. So absolutely still put your models on your visualizer like you would expect. And that gives the addressing for all your models. You can see here 100 count, 100 count. I've got nothing on port 3 and 4 in this example. But in this configuration, when doing an RGBW and you're mixing RGBW and RGB, I'm going to say never, ever hit this upload output on this WLED instance, because that will reconfigure our manual configurations in WLED, and it'll either maybe work correctly in xLights, but not in WLED, but you will not be able to get it to work correctly in both the WLED effects as well as xLights. So just treat this, yes, still do your assignment so you get the correct channel numbering on your models, but just don't do this upload output. Just just forget upload output at all, because it will overwrite and change your settings in here, and things will still be either incorrect in xLights or incorrect in WLED. You won't be able to get both working. And now I can do like, if I just, I don't know what Android effect does. I guess that's this. So I can do regular WLED effects if I want, and everything will be based on whatever color I select. And these effects work fine, and xLights works fine as well, both. Another reason why I do a preset in black, it just gives me a real quick, easy way to come back and just say set it back to everything off. So that's kind of the gist of the configuration on how I set up RGBW, and this works every time, all the way up through the latest of 14 versions of WLED. I have not tested or worked anything with WLED 15 yet. But any questions or comments? I know this was going to be kind of a short night, but I can go into more depth if need be.
No posted questions, bro.
Yeah, dark mode, dark
Can you
mode.
send warm white from xLights?
So if you're configured, so if you, let me go back and configure this in WLED. So if I configure it in WLED, it depends on your lights, correct, right? Back to my quick browser here. So with the 4-channel setup in WLED, this auto calculate white channel set to accurate means it will, anything that is a white or a component of white, it will send on that separate LED. So accurate means use the 4th channel. So if your lights, like in my case, are that's not on white, it's on orange. If they are a warm white, let me turn it off in WLED and then go to xLights. So in xLights, if I come back to my, let's take my on effect and send that to white. Then whatever white I send will be the white of the pixel. So in this case, these pixels are a warm white. And you can tell that that's, camera off. If I select the effect, camera on. So it's coming from xLights. So xLight is sending white, and where WLED is taking that incoming data and it's calculating that that's supposed to be white because I got 255, 255, 255, and it calculates that automatically, sends it out the 4th channel. In this case, these lights are a warm white. They're an RGBWW. And so every white from xLights will be a warm white.
Right, like what you just said, right? You'll never be able to get the same cool white at the same time with that accurate on.
With accurate, correct. Well, if your lights are a cool white RGBW with a cool white, depends on your particular pixels.
Oh, sure, yeah.
So
I'm
yeah,
saying that
so
the mix, you won't be able to get the mix.
your whites on RGBW and RGB, your whites will always be different. Just know that your whites will never ever match. You can get close by custom tuning the white colors and try to get, a correct offset and try to do like a 2700K warm white and mix, but it'll never actually match a real warm white. But if you want a cool white and you always want your whites to match, my recommendation in this case in WLED, set that back to none or brighter. Let me get back to my WLED here real quick and go back to my chats in the way. LED preferences, this auto calculate, find the setting, whether that's none or brighter or dual, whatever is the setting that matches your other pixels mix white as best as feasible. So that's a little bit closer of a match, not quite. If I come back here and change this to maybe max. And in real life, those look closer than they do in the camera to me. But you just have to try that setting. If you are trying to match, then you're not really in with these other settings, you're not really using the fourth channel, right? The fourth channel's there, but you're just not using it. But if you are configuring it, in this case, these are RGB warm white lights. So when I set this to accurate, I have other pixel strip and like do like interior cabinet lighting. And we have like 2700K, 24 volt under cabinet lighting. There's just a wall switch on and off, just builder gray, just single color, nothing special. And I have SK6812 pixel strip on the top that is specifically in a warm white. And then that matches quite well. But I'm doing warm white to warm white. But if you try to mix white, it's very hard to get RGB to match something side by side. There was in here DDP for WLED wafer bulbs. Absolutely, yeah. So you have like some of those Koff bulbs or Kaufman bulbs that run WLED in them. It's just going to be a single pixel and WLED. If your bulb runs WLED, the same thing will apply. If that bulb is RGBW, then this is how I would set it up. Yeah. Works good with E131. We'll try it. Yeah. So with E131, since I want to talk about that, so one of the other in your sync interfaces, if you're doing E131 and you want to do RGBW, you can do this DMX mode multi RGBW, right? So now that tells it to expect 4-channel RGBW coming in on E131. The disadvantage is this applies to everything on that entire controller. So if that controller only serves RGBW and you're doing E131, then in your ascending data, like in xLights in this case, you can configure it as a 4-channel and send it, and that would be fine. But you cannot mix RGB and RGBW on that same controller if you're using these E131 input modes, because this is an input mode for everything inputting into the controller, as opposed to individual mode for individual outputs. So hence DDP works really well. Just make sure in xLights, when you're using DDP on your controller tab, make sure this keep channel numbers is not checkmarked. That needs to be always unchecked with WLED controllers. Any other questions? If nothing else, we can probably return the room back. 7:40, is that a record for me? Probably.
Yeah, probably. Alex wanted to know what time it is, but I told him zip it.
Yeah. 7:40 Central Time. But your time will vary depending on when you're watching this video back, right? So really appreciate everyone's time and attention on this. Hopefully that helps clarify those that are trying to do a mix of RGB and RGBW on WLED controllers. And hopefully leveraging these settings like I've described, you'll just have complete joy and have your show working the way you expect it to.
Thank you, Ron. Thanks everybody for attending. With that, I'm going to stop recording and turn the room back over.
Thank you.